Okay, do me a quick favor. Take a second right now and just run your tongue over your teeth. You're going to feel sharp edges right in the front, some pointed ones near the corners, and then those big, broad blocks all the way in the back. Have you ever wondered why they aren't all just, the exact same shape? Why isn't your mouth just filled with one uniform row of pegs? Well, those varying shapes definitely aren't an accident. They actually tell an incredible, millions of years old story of survival. Welcome to This Explainer.
Today, we're going to look really closely at the mechanical functions of the different types of teeth. We'll see exactly how the shape of a tooth correlates directly with an animal's diet. Honestly, I want you to think of the mouth as a highly specialized toolkit where every single tool has a very specific mechanical job to do. All right, let's dive right in. Here's our roadmap for today. Number 1, inside the human mouth. Number 2, the 4 tooth types. Number 3, different teeth, different diets. And number 4, cracking the dental formula.
So, Section 1, inside the human mouth. Let's establish our anatomical baseline.
This layout of the human dental arch brilliantly illustrates exactly what we're talking about. Notice how the teeth are embedded firmly right into the upper jaw. And that numbered sequence you see along the curve, from 1 down to 8 on the right side, that is absolutely not a random assortment of bone. It actually represents a deliberate, highly organized arrangement of very distinct tools.
Moving on to Section 2, the 4 tooth types. Let's look at what these distinct tools actually are.
Biologically speaking, mammalian teeth fall into 4 distinct categories. First up, we have the incisors, which are located right at the front and are used primarily for biting off pieces of food. Next are the canines. These guys actively assist the incisors by tearing off that food. Then we move back into the cheek teeth. Here we find the premolars, which handle some of the initial grinding, and finally the molars, which do the heavy lifting for most of our grinding and chewing. And it's really important to point out that the muscles in the jaws are specifically designed to put a massive amount of force behind this grinding motion.
So it's a perfect example of form following function. Notice how that incisor on the far left is shaped almost exactly like a chisel, literally engineered for a clean, sharp bite. Right beside it, the canine is conical and pointed, making it the absolute ideal tool for piercing and tearing. Now contrast those highly specialized front teeth with the premolar and the molar on the right side. They don't look like chisels at all. They feature these large, flat, and highly uneven surfaces with pointed cusps. Those uneven surfaces basically act like a pair of millstones to just crush and grind down food. Which brings us to Section 3, different teeth, different diets. This is where form follows function on a macro level.
To break this down, let's compare the 2 major dietary groups. On one side, we have herbivores. If you look at the terminology, the prefix herbi means plant and vor means eater. Simple enough, these are animals that strictly consume plant material. On the flip side, we have carnivores, carni meaning meat. These are meat-eating animals that specifically have to tear flesh and hold on to struggling prey. Because their diets require entirely different mechanical actions, they fundamentally require entirely different dental toolkits.
Now, what's really interesting here is the sheer diversity of these categories across the animal kingdom. On the left, our herbivores range from grass-eating cows and deer to horses, squirrels, and even those towering leaf-eating giraffes. In the middle, the carnivores include lions and tigers, predators entirely built to consume meat. And then on the right, you'll see a third group, omnivores. Humans fall right here, along with pigs, bears, and chickens. Since omnivores consume a combination of both plants and meat, our dental toolkit essentially has to be a master of all trades.
Let's actually look at the visual, skeletal evidence for this. Check out the carnivore skull near the top. Notice those incredibly prominent, elongated canines, designed precisely for tearing and holding. Now compare that to the herbivore skull on the bottom left. You'll see a stark, obvious difference, a complete lack of those prominent tearing canines. Instead, that jaw relies heavily on a massive row of those flat cheek teeth in the back to just endlessly grind tough plant fibers. It's living proof that different types of teeth truly do equal different diets.
All right, final section, number 4, cracking the dental formula. This is basically like cracking a secret code.
Let me show you how this biological code works. 2.1.2.3. This specific sequence is the human dental formula. But what does it actually mean? Well, this formula outlines exactly half of the upper jaw. It tells us that in just one single quadrant of a human mouth, there are exactly 2 incisors, 1 canine, 2 premolars, and 3 molars. And because the jaw is completely symmetrical, to find the total number of teeth in the human mouth, you simply take these values and multiply the whole thing by 4.
So let's actually put this code into practice. We are comparing the dental formulae of 3 mammals here.
a human, a horse, and a leopard. Looking at animal A, we see that familiar 2-1-2-3 pattern in the upper and lower halves, which we just established is a human. But look at animal B. It has 3 incisors, 1 canine, 4 premolars, and 3 molars in those quadrants. That heavy, massive emphasis on premolars and molars points to an animal that needs to do a staggering amount of grinding. That is our herbivore, the horse. Contrast that with animal C, which only has a single molar per quadrant. It doesn't need a huge row of grinders for plants. It needs teeth to slice meat. So that's our carnivore, the leopard.
So we've traveled from the specific chisels and grinders sitting right there in your own mouth to decoding the diverse diets of the entire animal kingdom. And I want to leave you with a final thought to ponder today. If you are out hiking and you found an unidentified skull in the dirt and it had large, flat, uneven molars but absolutely no canines, what incredible story would those specific teeth tell you about how that animal lived and what it spent its days eating? It's a fascinating way to view the natural world, knowing that every single jawbone is essentially a permanent evolutionary record. Thank you so much for joining me for this explainer, and keep exploring.